In the previous video, we focused on the first quadrant angles pi over 6, pi over 4, and pi over 3, and determined the trig values of those specific angles, the sine, cosine, and tangent of those angles. Obviously, those are just the first quadrant angles, and that only gets us through 25% of what we want to do. So we want to be able to apply what we learned in the first quadrant to all four quadrants and come up with the trig values of any angle. And so when we do that, so to determine the exact value of any angle, you must place it in the correct quadrant to determine the sign of the value. And that's really the key thing here. The values aren't going to change. We actually established all of our values when we looked at the first quadrant. The only thing that's going to be different is that depending on which quadrant it's in, the x value may be positive or negative, the y value may be positive or negative, and that may also affect the way that tangent behaves because that's the y value divided by the x value. So let's just consider an angle here. Let's consider the angle theta equal to 7 pi over 6. Now then, it's going to be really important if we wanted to sketch a graph of this that we understand where 7 pi over 6 is. And it maybe would be nice if we could kind of sketch the quadrantal angles here. So obviously if we're at our positive x-axis, that's going to be an angle of 0. If I open it up exactly 1/4 of the way and I get this positive y-axis here, I've gone 90 degrees, or as we'd like to think of it now, that's going to be the value pi over 2. If I go all the way here to the negative x-axis, where I've gone now half of a circle, well, half of a circle we know is pi radians. And then if I go another, what you are probably now thinking of as 90 degrees, another pi over 2 is going to be 3 pi over 2, and I will have made my complete revolution once I have gone 2 pi radians. So those are kind of the quadrantal angles, which will help us understand when we take a look at 7 pi over 6 exactly where it's supposed to go. And I can see here that as I open it up from the positive x-axis, I go pi over 2, I go pi, and then I need to go another pi over 6 to get 7 pi over 6. And so my angle is down here in quadrant 3. And I know that I went pi plus another pi over 6. And so I'm working with a pi over 6 right triangle here, the ratios of which are 1, the square root of 3, and a radius of 2. And what I have here is I now need to take a look at my x and y values and realize I'm in quadrant 3, which means that this square root of 3 really needs to be negative square root of 3. And the 1, because it now dips below, is really negative 1. The radius is always going to be positive. It's looking at it more from an absolute value standpoint. So the radius here has a value of 2. Well, now I can go and apply my relationships. Once I have that labeled, I can say the sine of 7 pi over 6 is equal to y, negative 1 over r. So that's negative 1/2. I can say the cosine of 7 pi over 6 is equal to x over r, which is negative square root of 3 over 2. And then when I talk about the tangent of 7 pi over 6, which is equal to y over x, well, y over x is negative 1 over negative square root of 3, so I've created a positive value. It's equal to 1 over root 3, or the square root of 3 over 3. And so you'll notice these values are the same values we had when we talked about the sine, cosine, and tangent of pi over 6. But because I was at 7 pi over 6, which placed me in quadrant 3, sine and cosine became negative. And so one of the strategies that you'll develop as you get quicker about this, you'll recognize if I'm talking about 7 pi over 6, it's going to have the same values as pi over 6. I just need to place the correct signs based on which quadrant I'm in. And there's actually a mnemonic here. So we're going to kind of come over here. There's a very famous mnemonic that gets passed down to calculus students to help them kind of memorize or visualize the signs of all of these angles. And the mnemonic is called all students take calculus, which is very fitting for where you are now taking a calculus class. But what it's done is it's used, this mnemonic can be used to remember the sign, the SIGN sign of each trig value or of each trig ratio in each quadrant. All right, here's how this mnemonic all students take calculus works. If you'll draw yourself the coordinate plane, split into 4 different quadrants. And remember, your quadrants are numbered 1 through 4. 1, 2, 3, 4. If you'll take the letters of all students take calculus and apply them in that order, all students take calculus, then you get an idea of which trig ratios are positive in which quadrant. In the first quadrant, all of the trig ratios are positive. And so you can remember it, that's what the A stands for. It stands for the same all that's up here. Over here in the S category, the students category, quadrant 2, the only thing that is positive is the sign values. And that makes sense because the Y values are still positive. However, in quadrant 2, the X values become negative. Down in quadrant 3, both the Y and the X values are negative, but as we saw over here with 7 pi over 6, that makes tangent positive. And as you can probably deduce in quadrant 4, where X becomes positive but Y is negative, then the positive trig ratio is cosine. So this is kind of what develops as you start to get really good about, let's say that you're asked, hey, what's the tangent of 5 pi over 4? You go and figure out, okay, 5 pi over 4, if here's pi, so another pi over 4, I'm in quadrant 3, that means that it's positive, and you know that the tangent of pi over 4 from what you learned in the other video is 1, so you would say the tangent of 5 pi over 4 is 1, and that's kind of what mentally starts to happen the more and more practice that you get with this. Now then, one other thing that we need to make sure that we address here, and that's what we'll do in this space, is we need to also make sure that we address the quadrantal angles, which we labeled up here. And remember, this kind of occurs, a lot of times you'll hear people refer to things like the unit circle. So I'm going to use those values for this. So here is 0 and 2 pi. Here is pi over 2, pi, and then 3 pi over 2. And if you think about a radius of 1, I can say this is the point 1, 0. I can say this is the point 0, 1. This is the point negative 1, 0. And then I can say that this is the point 0, negative 1. And then I'm going to make a little table here of the sine, cosine, and tangent of these angles, 0, pi over 2, pi, and 3 pi over 2, with the understanding that 2 pi is going to place me back at 0. Well, remember that the sine values, which are associated with the y values, for 0, that's going to be 0. At pi over 2, sine is equal to 1. At pi, it's back to 0. And at 3 pi over 2, the y value is equal to negative 1. Cosine, which is associated with the x values, so the cosine of 0 is going to be 1. The cosine of pi over 2 is going to be 0. At pi, that's where cosine is equal to -1, and then the cosine of 3 pi over 2 is back to 0. And now when you look at tangent, which remember is the y value divided by the x value, or for this particular case, we can look at it as the sine value divided by the cosine value. 0 divided by 1 gives me a tangent of 0. The tangent of pi over 2, 1 divided by 0, is going to be undefined. At pi, 0 divided by -1 is going to be 0. And 3 pi over 2, the tangent of 3 pi over 2 is also going to be undefined. So you also want to make sure you understand these quadrantal angles, how the y and the x relates to sine and cosine respectively, and that tangent, it's just y over x, can also be viewed as the sine of an angle divided by the cosine of angle. If you can apply this logic, you'll be able to come up with the exact trig values of any angle.